What's bond line? You're like, oh my gosh, I forgot that. It's in your reader, if you forgot about it, at the beginning of chapter 3, in this quarter, on the top of page 3. It's a type, top of page 14, sorry. It's a type of drawing. This is bond line. You're like, oh my gosh, thank goodness. So I would ask, a common question would be, how many carbons and how many hydrogens do I have? How many carbons here? 5. How many hydrogens? That slowed you down a little bit. I got 12. 1, 2, 3. Remember, every carbon has how many bonds? 4. So I need to, every missing bond is a hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, where I'm putting 4 total. 10, 11, 12. Okay, let's do one hard one. Is that good? Yeah, all right. Crazy hard? Oh, we'll just do hard. Do hard. Oh, boy, here's the good. Ooh, yeah, this is, I'm loving this right now. Oh, I love it. I really like this one. The exam would be on this order. You'll see practice, but on the practice exams, I'd probably give you a chunky looking molecule like this. It has a lot of atoms on it. Could have a couple rings, stuff like that. Okay, carbons. And I'm going to do hydrogens next if you want to work ahead. I have to count 2 because I just made it up. Okay, I'm ready. Did you get total carbons? How many? I think I got 9. Let's double check. 1, 2, 3, 4, 5, 6 in the ring. 7 right there. That's an oxygen, no. That's a nitrogen, no. 8, 9. Is there any one you were confused about? Was it these? These are 1 carbon each, remember? Okay, hydrogens are harder. I'll give you a head start. I have to count 2. Okay, I'm ready. What do you got? 11. I think I got 11. Yeah, that looks good. Let me use a different color. Remember, every carbon has 4 bonds. 1, 2, 3, 4, 5, and then 6. One's just written. No, not there. That's not carbon. That carbon has 4 bonds. This carbon has 4 bonds. Shoot, I forgot where it was. 6, 7, 8, 9, 10, 11. Here we go. Is there any confusing part of that you want to ask me about? Yes? Per. Why on the left, why is there only 1 hydrogen per? Because each of those carbons already have 3 bonds. If you look at this one, there's 1, 2, 3. This line is a bond, that's right. That's a bond. That's a bond. That's a bond. That's right. It's pretty normal for rings to look like that. Any other last questions before we go to the next topic? Yeah, I see you.
Why is there no hydrogen and the oxygen in the middle?
Why is there no hydrogen right here?
Yeah.
Yeah, the oxygens, unless the oxygens and the nitrogens or any other entities like sulfur, etc., will have the hydrogens drawn in for you. And that's really normal in organic chemistry, that we draw those. We don't draw the ones on carbons, but we draw the rest. And actually this has what's called lone pair electrons, and that fills up what's called an octet, as you'll learn at the end of the quarter, 2A. All right, but we don't draw those in. That takes a lot of time to put dots. So it gets my arm tired. Okay, naming. Let's do naming next. Naming. All right. So you just want to practice with a bunch of different craziness. have a bunch of videos online. Yeah, that's good. And in a second, I will tell you how I would practice. Okay. Here's how I would practice. I would have my nomenclature template out, which is in the handout and in the reader. If you like that style, if not, you can write it out in lists. And basically, I would watch my videos. I have a bunch of them on naming. I would pause before I answer the question, and then see if you can get it, and then just go from there. This just takes rote practice. As you get used to it, it gets easy. It's easy for me just because I've done it a lot. Same for you. There's really no faster way of doing it besides practice. This is one of those, unfortunately, you do have to memorize a number of things, like how each is named and that sort of thing. I got one more. Okay, that's a fun one. Okay, we'll leave that till later. So first, I always start with identifying what it is. I've got a metal here, so this is ionic. So I'm going to name it according to ionic binary. I know that the oxygen is -2. Oh, I care about the charges. Why? I have a transition metal, and the transition metal needs to list the charge. So this must be +2. I can name this in English or Latin. In English, it's iron 2 space oxide. In Latin, it would be ferrous. Us means lower charge, 2 versus 3. Ferrous oxide. So iron 2 oxide or ferrous oxide. Okay, next one, it's ionic because I have a metal and there's a transition metal. But there's a question here? Yeah. Good question. You can't name it iron 2 monoxide. Why is that? Yeah, you can only put prefixes, mono, di, tri, etc. if it is molecular, no metals. Because this has a metal, please do not name subscripts. That is a common mistake on the exam, so just be really careful. If it's an ionic, please do not name subscripts. I've got a chromium here. This is ternary. Chromium, I need to know the charge on it. Acetate is -1, so chromium must be +2. So chromium 2 acetate. This is the acetate ion, so it's just called acetate. You could call it chromous acid as well, because there is a Latin equivalent of chromous acetate. Okay, next one. What category is this one? Molecular, there's no metal. Now, please name the subscripts. You don't need to name this first one if it's mono. So here you can just say sulfur, space, now name the subscript, di, and this is sulfide. Sulfur, wait, no, sorry. I'm crazy. I need to go home and watch TV. Dioxide. Okay. Alright, okay. Next, what category is the next one? Ionic. There's no metal. This is the one in case you might not see a metal if you see the ammonium ion. The ammonium ion is one situation where you wouldn't see a metal, but it counts as an ionic because of this NH4. So this is it's a ternary. It's got more than 2 different types of atoms, so you use the ternary style. Ammonium, space, what's this called? Oxalate. So I don't have a transition metal, so I don't need to name the charge or the oxidation state. Next, I have aqueous acid that is a binary. So the key to this is to write the hydro. Hydro if it's binary. Then the stem name of the anion, it's fluor. What's the next letter? Not flower. Fluor. That's a common mistake to write fluoride or whatever, fluoride. Okay, fluoride. All right, fluoric. Sorry, hydrofluoric. I got too excited about the flour. Space acid. Hydrofluoric acid. All right, these are ternary, the next two. So now I need to know the name. I don't need a hydro, but I need to know the name of this anion. It is called nitrite. So the ite changes to an us, nitrous acid. The next one, is, yes, okay, is a nitrate, so it changes to nitric acid. Okay. Any questions on any of these? All right, we're going to go to our next topic. Oh, yeah, the last one. Okay. This is alkane, organic, the straight chain. So you need to figure out the number of carbons, which is 8. So that's oct, like the octagon, and then the suffix ane, octane. Like the high octane gasoline, same sort of thing. Okay, now what's the next one? Let's do combustion analysis. I might need to save that for later because I don't have an example of one of those. So I have to save that for later. If you have an example, if you ask about this question, please look up an example in your practice exams. Let's take a look at isotopes, and then I'll dismiss those of you who are ready to go. Isotopes is a common question on the exam. Remember that it's a weighted mass. So for isotope, you need to know that atomic mass equals the sum of the isotopic mass. That's the mass of the isotope, times the percent abundance, or really the fractional abundance. So whatever the percent is, you'll divide by 100. You sum all this up and you get what's called the atomic mass. The atomic mass is found on the periodic table. So if you take a look at some examples, there's a lot of good examples in the textbook or in the practice exam. I took my chapter 2 out. A common example, though, you'll see one of these in the practice exams. I think I've done one of these a couple times. There's one with boron 10 and boron 11. This is a harder example, so let me just run through it for you, okay? What they're going to do, and I forgot the exact numbers for this, so I'll just make it up. Let's say this is 10.01 U for that isotopic mass, and let's say this is 10.98, okay? I just made that up because I don't have that exact numbers. And we want the percent abundances for both. Okay, I want the percent abundances. So, and they want you to solve for that. So there's two unknowns, each percent, for 10 and for 11. Let's set this up. First, the atomic mass you get from the periodic table. Sometimes it's given. Okay, it's 10.81, so you expect more of what, 10 or 11? More of 11. If this was multiple choice, I would be crossing out all the ones that are not more of 11. Okay? And then guess randomly if you have no time. Okay, the isotopic mass for 10.01 times, let's just call the percentage, or the fractional abundance x, plus 10.98 for 11, and let's just call that fractional abundance y. So notice I have two unknowns, x and y, but I also know one more thing. What is that? X plus y, as I've written the equation, is what value? 1, okay, because it's a fraction. All right, so what I would do is I'd say, well, y equals 1 minus x, and so I rewrite your equation. 10.81 equals 10.01 x plus 10.98, 1 minus x. And then I would simplify the right-hand side, 10.01 x plus 10.98 minus 10.98x. And I go, well, this is negative, what, 0.97x? Did I do that right? Yeah. Plus 10.98. I take the 10.98 to the other side. 10.01 minus 10.98 equals negative 997x. And I kind of solve from there, if you kind of get what I mean. So solve for x. Once you have x, you'll have y. Are x and y my answers? No. What do I need to do to x and y? Multiply by 100, because I need the percents. Okay, so once I find it, solve for x and y, and then multiply both of those by 100 to change it to a percent. Okay, I didn't do one of those in class, but that would be the hardest, a hard version of this question, where I have you solve for the percent abundances. And you'll see some practice examples in the exams and in the textbook. All right, any questions on this?